Hi, everybody. Welcome to another episode of YFTT, Yugabyte Friday Tech Talks. This is just a talk from engineers, of engineers to engineers, right? So it's just supposed to be a free-form format where we discuss various features, what went into building them, how they work, showing demos, et cetera, right? If you guys have any questions, feel free to drop it at the chat box. You can also alternatively join our community Slack at yugabyte.com/Slack and find the YFTT channel. You'll be able to ask us questions at any time there. Okay, so without further ado, let's get started. We're going to be talking about GIN indexes or generalized inverted indexes, but a quick intro before that. I have the man who worked on GIN indexes for YugabyteDB. Jason Kim, you see him styling his way here in this talk. So Jason, maybe you want to quickly introduce yourself.
Yeah, I'm Jason. I joined Yugabyte about 2.5 years ago and worked on various projects, but one of them being GIN indexes, which has been what I worked on for the past year.
Awesome. And so folks, yeah, you can hear it from the horse's mouth, right? Like what got built, how it works, what's coming, et cetera. Okay, so Jason, do you mind first telling us about, what are generalized inverted indexes or GIN indexes?
Yeah. So unlike regular indexes that index just columns and make lookups on columns fast, GIN indexes index elements inside container columns. So container columns can be like these types: TS vector, arrays, or JSONBs. And for example, with TS vector, it will be like a bunch of words.
So TS vector is like, I guess it expands to term search vector, right? Like, and it really is the set of words inside that sentence that are not stop words, right? Like the is stripped out and now you get a tokenized set of words. Is that the way to understand it? Hey, Jason, you're on? I can't hear you. Maybe it's still audio still.
T1.
Okay, I think there was a pause. So maybe if we can go back to the previous slide. Sorry, Jason, I think there was a freeze, but yeah, I was just asking about TS vector. Is that is the way to understand it? Is that just like term search vector where it gives you the tokens, the set of words inside a sentence?
So yeah, the TS vector has you can say tokens and also like a couple other features on top of it. But yeah, like for our purposes, we're concerned with like the individual tokens.
Got it. And JSONB is the document data type in PostgreSQL, right? For those of the folks that are not aware.
Yeah, all right. It's like, yeah.
All right. Yeah. So yeah, keep going.
Yeah. So in this example, I have a table T1 with K int primary key, and then two indexes. One is a regular index on the text column, and the other is a GIN index on the array column. And then if I insert this one row, then my table index and like the two indexes, they roughly look like what you see on the right side.
Okay, so delving more into it, because the text column index is a regular index, you get the entire text column content into the index and it points to the row in the primary table. But because the GIN index works on the container column, you get one entry for every entry in that container, right? Like,
yeah, and also it's deduplicated.
It's deduplicated too. Yes, I2 is deduplicated. There's only one O. Yeah, makes sense. Okay, let's keep going. Yeah.
And then just another row. So yeah, it's like the same thing.
Fantastic.
And then when we select from this table with a filter on the text column, we will use an index scan using I1. Mm-hmm. So we'll scan for the word world and then get the primary key reference to and use that to look up the entire row and return that entire row. When we select on the array column, and this operator means like looking for the elements E.
So what does this operator do? So this query searches for what?
So if the A column contains the array on the right
Got
side.
it. It contains E, right? Like if that, because it's a container type, right? Like if that container contains E, it's going to return all those columns. Is that right?
Yeah, you can have multiple, like the array on the right side can be larger, but in this case, since it's only one element in there, it will act as if you're looking only for E.
Got it.
In the A column.
Uh-huh.
So we can look that up in the index, and then that will also reference 2, and we return that entire row. And if we do the same for F, there's 2 matches in the index. So we'll go look up both of them and return both rows from the main table.
Got it. And because it's a distributed database, right? Like just to ask the questions, are these global indexes? So that means if I have a bunch of nodes, like I have like a lot of these rows and I have a bunch of nodes, can I address them globally across the cluster?
Yeah.
So the indexes themselves are sharded, distributed, replicated across the cluster, right?
Yeah, and they can be on separate nodes.
Got it.
It doesn't really matter.
Got it. Fantastic. Okay, let's keep going.
Yeah. So
I guess, yeah, now let's talk about what's supported, right? Like, yeah.
Mm-hmm. Yeah, because of Postgres reuse, a lot of the JSON code comes for free. So for example, temporary tables support was very easy. And same with insert, delete, and update. Like a lot of the higher level processing is done for us. And also just handling the different types, so we don't have to really manually do much work. It's just once we get the whole thing working, like the types usually come for free. And extensions, for example, like they usually add support for other types, but those also are pretty easy to integrate.
Awesome. Fantastic. So most of the Postgres functionality should be something that, you know, with respect to Gin, which is quite rich, right? It's got a lot of functionality, should just work. So, so what's not supported? What does not work?
Yeah, so some things that we still have to do, you can find it in this roadmap tracking GitHub issue, but I list them here. They're multi-column support. So right now you can't create a Gin index over multiple columns. And then certain selects don't work. Like right now it's like mostly point selects on the index. Like you can't, like for example, it's hard to, or we can't do an OR scan where you're scanning for 2 different entries in the index at the same time. And also some custom estimates, like they're partially supported, but there's still a few edge cases. But that's, you can just override it yourself if you like manually like turn off, like disable index scan.
Got it. Got it.
And then some extensions are still in progress. So right now the extensions that are supported are PG_TRGM and HStore, but btree and interray.
Hey, Jason, you're
Finally,
on?
it's fast
Yeah,
update.
I think you cut out for a little bit, but yeah, I think that's fine. Yeah, I think I think what you were trying to say is some extensions are not supported, right?
Okay, yeah. And then fast updates, another thing that's comes from Postgres, where you like the inserts are kind of batched together in a sort of cache and then later on like flushed out. We don't have that for Yugabyte.
Got it. Awesome. Okay, so let's go over to the demo. There's a question about does an explain plan show the index used Gin versus regular? I mean, you could just like maybe give a one-line answer, but maybe we'll just show it during the demo. I would like explain plans do show Gin indexes, right, Jason?
Yeah.
Okay, great. So yeah, I think Jim, the answer is they do, but let's go into a demo.
So let me first turn on some settings, and I'll skip the JSONB demo first, and we can go back to it later if we want. But
Okay.
right now I'm gonna cover, I'll just show what the data loading is. I already did this before, but
yeah,
maybe you can review it, the recording if you want. But there's this Jeopardy table. I found a Jeopardy data set and
the Jeopardy
loaded it
data set. Got it. Okay, always fun to see a real data set. Yeah, great.
Yeah, and let me select an example of one of the rows.
Okay, great.
Turn on extended display. Yeah,
Nice.
so you have like answer and question, and also the answer is a TS vector. Like I converted the answer to a TS vector.
Great.
And turn that off again. And so let's go.
So where do you declare the index in this? Yeah, where do you do? Okay, so that's the create index on JPDY using Gin, right? That's the place you create it. And there's a question, I think we did answer it, but once again, is the index stored on the same node with the data referenced by the index? For example, if a record with primary key 10 is on node A, then will the index be placed on node A, right? And I think for what you said, Jason, it's not, right? Like it won't. It'll be a distributed. The index itself will be distributed. Jason's probably having some Wi-Fi issues. Hey, Jason, you're on. Okay, so while he brings that up, I think, I think Jim will take a look at the explain plan to show how GIN indexes are used. I think Kurt asks a question about GIN indexes that pose challenges for a distributed database, which accounts for why some GIN index features are not yet supported. Our aim is to eventually support it, right? Like we do want to support it, most of the features at least. It's just the complexity of how GIN indexes work with other things as well, right? So there's no, I'd say for most of the limitations that we have right now, there's no inherent complexity because at least in implementing it now, whether it'll be an optimal execution path or not, that really depends, right? That depends on a lot of other things. There are some things though, for example, extensions that work closer to the storage layer that, obviously won't work with YugabyteDB because our architecture is we rebuild the storage layer completely, right? Okay, waiting for Jason. Apologies, folks. I think Jason is having some Wi-Fi issues. I'm trying to find out what's going on. Yeah, sorry, folks. Some Wi-Fi issue going on. Not sure what's going on with Jason. Trying to see if he lost Wi-Fi or maybe power. I'm just trying to figure out what's going on. Give us a minute, folks. So we really apologize for the hiccup. Jason just said he's going to reconnect. It'll be a minute. He'll be back in. Some of the things that we wanted to talk about are, well, there's a suggestion that I sing a song, but I think the rest of you would really drop off in a hurry if I did that. Anyway, so some of the things I'll just stick to what I know. We'll talk about some of the things we're going to see. Okay, and there's Jason, even if there's two of him. Okay, Jason, do you want to take it away? We start presenting the demo and continuing from there.
Yeah. Can you hear me?
Yes. Yeah.
Yeah. Sorry about that.
No worries. Perhaps it's okay to keep your video off if it's causing bandwidth issues.
Okay. Let me see, where was I? Oh. Okay. MySQL SSH. Okay, I'm back on here.
All right.
And the demo.
Okay.
And
so, yep, we're back. All right. Let's, I think we did the select. Yeah, now let's do this. Yeah.
All right. Yeah, I wanted to.
So you have you have a function here, right, called cell. What does that function do?
Yeah, it's simply, or it's not, it's kind of complex, but we're kind of, so we have the, like it's just making some fancy headline on the query when we're selecting the query, and also ordering it by rank.
Got it.
Kind of the important part is so for the answer vec column, we're querying on the input query, which is filtered, converted to TS query.
Got it. Okay.
If I try this, and it'll give us these results. So it's able to find the YB in the answer. And also, let's try to see if there's Yugabyte, and no, it definitely doesn't have Yugabyte yet.
So perhaps to answer Jim's question, can we do an explain on one of these? Maybe the next one you could just do an explain on. Yeah.
Let's explain first.
Okay.
Right now it's a function. Let me explain the raw. So I'll do the answer like at query on databases.
Yeah.
Let me see. Oh, the table name is PDY.
Yep.
Yeah. The next condition.
Okay. So it is going against the answer vec IDX, and can we describe the table too? Yeah.
Yeah. So this, it's a gin.
It's the YB gin. Yep. So as you can see, I think who asked that? Somebody asked that. Like you can see it on the explain plan. Okay. So let's keep going.
Yeah. And if I do the select using the. I'll just show this one, this last one here.
Yeah.
So you can even do complex things like not things that don't contain the word data, don't contain the word database, and start with
contain data something. Okay, got it.
And you get the word datable.
Okay, great. And what does an explain plan on this type of a query? It's a cell query. Okay, never mind. We can do that. Yeah, that's fine. Yeah.
You can do the more explains on the other examples. So here's let me change the. Great to see.
Yes, great. Okay. Yeah, let's do the trigram extension. That's pretty interesting. So trigram is typically used to figure out languages or like do that 3-byte match, right? Is that what it is?
Yeah, it's like it would convert like the 3 or so consecutive letters into like a number.
Yeah.
So the index is containing 7 numbers.
Got it. Okay.
So I already did the create extension and the create index.
Yeah.
And then let's select, yeah, it's free. Let me turn timing on and run that. So run it again just because of the caching. So yeah, so it takes like 4 milliseconds. And so this is like a regex match on ABC, and you can see there's ABC in the question here.
Got it. Now, if you describe the table again, so right, so the index that this thing uses, right, which is I'm guessing the answer vector. No, hold on. Which is the
question.
Yep, the question index. Yeah. So that gin trigram ops is the function that you pass into YBGin to make it actually use the trigram based indexing, right?
Yeah.
Okay, got it. Awesome. Awesome. All right, let's keep going.
Yeah, and then let's try to temporarily disable the index scan. So
okay.
Enable index scan, go off, and then try running it again. Let me explain it first.
Yep.
So now it'll be sequential scan. So if we run it, it's going to take a while.
It'll take forever, yeah, because it has to do the regex match on the entire text, right, as opposed to looking it up the index.
Yeah, we would have to do a full scan. So, well,
awesome. Yeah.
Okay, this one took 17 seconds, but it leaves out caching. Some cache might have been involved. If you run it again, it should take a little less. So yeah, like 7 seconds.
7 seconds. So yeah, we go from 7 seconds to like 4 milliseconds. Or yeah, that's huge. About 1000x improvement, right? Yeah.
Yeah.
Great, great, awesome. I think one question: how many rows are in the Jeopardy table?
Let me see. So 350,000.
See, 360,000, something in that range. Yeah. So that was Jim's question. Okay, great. And obviously the issue is not just the 350,000 rows, it's the container columns, which have even more stuff inside, right? And depending on trigram, that's even more explosive in terms of the search space, right? Okay, so let's keep going. Let's talk about like what other stuff you have. Okay, can we talk about stop words and stemming and other advanced features, or maybe let's look at JSON, the document data type, or
do the stop words and stemming. So there's Postgres has this extension on accent. So we can use it to like when we're like to remove the accents from words.
Got it. So this an example would be if I had cafe, right? With the okay, you have that example. Okay, so maybe we should just look at that. So cafe, but in English, I might just type CAFE without the accent on top of the E, and it should match.
Yeah. So let me run this. And right now the alter, I just want to call out that this is not in the code like releases right now. It's
in progress. Got it. You have a more advanced version. No worries. We'll wait for it, the rest of us.
Okay, and then I'll load some data. So get this TS vector table, and also, by the way, this is a local RF3 cluster.
Got it. No worries. Yeah.
Right now, this, for example, some reason the terminal is not showing the accents here. But
got it. Yeah, but in theory, yeah, got it. And now you should be able to just search for that using the word cafe, right? It's your terminal eating it up. Makes sense.
Yeah. So let me first show what's inside. And thanks to this is like Postgres already did for us, is when we convert this to TS vector using the FR text search configuration. And
I think for those of the folks following along who understand French, right, like the words de and la, which are like stop words in French, are removed from the index, right? They don't exist in the index anymore.
Yeah.
Right. So it's the stop word pruning because it's like the English the and off and all of that stuff, which is not useful in a text search. Okay, so let's go back. That's exciting. All right, let's see what else can we talk about. Can we talk about JSON data type? And if you have like indexing on that? Like, or did we already cover that? Like, did one of the examples already have it?
No, we didn't cover JSON yet, but I can. So I'll show this small table with getting the GitHub contributor information.
Got it.
Using
Nice.
the GitHub API.
Okay.
In a JSON format.
Okay. So let's maybe describe that table and then, or do you have the data set ready, or you have to load it now?
I have it ready.
Okay, got it.
It's the contributor table.
You want to start?
It's kind of a nasty looking table, but yeah.
Got it. A lot of stuff. Okay, I think, yeah, that's fine. We get the idea.
And then we can look up, so it's like whether the column contains this path. So
got it.
Author, login, Karthik.
Okay, I've been coding in.
And this is also kind of
there's something there. Yeah.
But this JSON contains like a total commit count. And then it looks it up really fast.
That was pretty cool. Can we do a explain on that?
Yeah.
And also look at the /d on the table.
This one's, oh, I still have the, I may reset
index. Is there, yeah, this is, yeah, enable.
Let's do it again and run it again as well.
Yeah.
Yeah.
Got it. And what does the explain look like here?
Explain after I.
Oh, you did run
index again.
Yeah.
It is the.
And can we do a /d on the table itself just to look at the indexes?
Yeah.
Got it. So this is basically your very, very simple document app, right? Your application that's purely document oriented, no schema, just a primary key and a JSONB, which is like a pure document. And in that you have a index, which is YBGin on the path ops. So you'll be able to query all the document paths, right?
Yeah, there's like two, there's also a JSONB ops that's more for like generic key or value lookups. This one's like optimized for paths, like such as like this.
Fantastic. Fantastic. Okay. So one question that came up, I think, as you were reconnecting, is there something about GIN indexes that pose challenges for a distributed database? And does that account for why some of the GIN index features are not yet supported in Yugabyte?
So for the distributed database, the fast update would be something that is not that easy to map to a distributed database, because that's like a sort of like a cache. But
got it. It's a local cache. Got it. Yeah. Okay.
And then regarding challenges, so one of the things that was a challenge specifically for Yugabyte is that we don't support bitmap scans yet.
Yeah.
But
Frank mentioned that. Yeah.
A lot of it is like, or first of all, a lot of the code base was using bitmap scans, so a lot of that had to be reworked, and that's still in progress with the select support. So in the future, when trying to support all the different types of selects, it might become tricky to, and we might have to go with bitmap scan.
Awesome. Awesome. All right. Thanks a lot, Jason. I think that brings us to time. So folks, feel free to ask us questions. Again, join our community Slack, yugabyte.com/Slack. Go to the YFTT channel. Feel free to keep asking us questions. It was like a pretty lively session, a lot of good questions and a great demo. Thanks, Jason. I think not one, but two standard and interesting data types, right? Like we picked both the Jeopardy and the GitHub contributors, and that's awesome. That's great. Thank you. Thank you, Jason. Thanks, everybody. See you next week. Same time, same place. See you guys.